We need to find out f dash of x greater than 0, f dash of x less than 0, f dash of x is equal to 0. If it exists, we need to find the critical point. We got the positive values, that is f dash of x is greater than 0, so therefore it is increasing function. Now let's find out the critical point if exists. Exponential function can never become 0 for any point of x. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in today's session, we'll be discussing another important application of derivative, that is to find increasing and decreasing function. Suppose whenever any function is given, so when we say that the function is increasing or decreasing at a given point or an interval or a domain. So let's see it now. Here we have increasing and decreasing functions. So a function y is equal to f of x be a continuous function defined on an interval I. So then we take two numbers x1 and x2, the real numbers, 2 points we can say from the intervals. Then f of x is said to be increasing. So in any interval, if you take a comma b, it is clear that a is always less than b. Suppose you take any 2 points x1 and x2 from this interval, it is clear that x1 is always less than x2. So therefore, a function is said to be increasing in an interval where x1 is less than x2 such that f of x1 is less than or equal to f of x2. So when this condition holds, for this condition, we say the given function is increasing function, and it is said to be strictly increasing if f of x1 is strictly less than f of x2 for given 2 points. Next, decreasing in an interval x1 less than x2 if f of x1 is greater than or equal to f of x2, and it is said to be strictly decreasing if f of x1 is greater than f of x2. So here we have taken 2 points and finding whether the given function is increasing or decreasing. So look the graph here. So we have two graphs here. So this is an example for increasing function. This is an example for strictly increasing. So for any point here, somewhere for each value of x, the f value is also increasing. At certain point, it is constant. Then it starts increasing for each point. So here, it is almost increasing, then constant, then increasing. So this is an example for increasing function. So for example, here you can see f of x1, 2 and f of x2. If you take, the value is same. So therefore, even though x1 is less than x2, it is constant for some point. So therefore, this is an example for increasing function. Here, both f of x1 is less than or equal to f of x2. So this is the condition for increasing function. So here, you can take this as x1 and this as x2. At any point you take, the function is strictly increasing. That means for each point, the value of f of x is also changes. So clearly here what we can write, f of x1 is strictly less than f of x2. So here it is x1 and this is x2. So here we have taken a graphical representation. We can observe two graphs here. One is increasing function, one is strictly increasing function. Why this is increasing function? Suppose you take any two intervals, x1 and x2. So f of x1 and f of x2 is different. Suppose you take x1 and x2 here. So then f of x1 and f of x2 is same. So for some values of x1 and x2, the value of f of x1 and f of x2 may be equal or less than. So therefore, this is an example for increasing function. Clearly, you can observe here for each values of, suppose I take this as x1, x2. So the function here, you can clearly say for any point interval, it is strictly increasing. So there is no point that where f of x1 and f of x2 are same. So we can clearly say for each point on the x-axis, the value on the y-axis is increasing. So therefore, this is an example for strictly increasing function. Next, we have decreasing function. So if you take this as x1, y1 is different. This as x2, y2 is different. So it is decreasing. And somewhere at some interval, for all the values of x, the function is constant. So clearly what we can write here, f of x1 is greater than or equal to f of x2. It may be greater than or it may be equal to the second point. So therefore, this is an example for decreasing function. And here if you take this as x1, x2, for x1, this is the y1 you can take, for x2, this is y2 you can take. So here, for each point of x, the value of y changes. So that means there is no constant value here. So therefore, it is an example for strictly decreasing function. Now, coming to an important topic here. So when the function y is equal to f of x is increasing, then its derivative is always positive. So by the help of derivative, we can find whether the given function is increasing or decreasing. So here, you can see the derivative of a function, that is f dash of x. If f dash of x is positive, we say the function is increasing, and similarly if f dash of x is negative, that is less than 0, we say the given function is decreasing. Here there exists one more case. At particular point of a given function, the function is neither increasing nor decreasing. If you draw a straight line to the curve, it is tangent to the curve. That means a line touches the curve only at one point is said to be tangent. So at that particular point where the line is parallel to x-axis or tangent to the curve and parallel to x-axis, there that point is said to be a stationary point. The stationary point is nothing but there the function is neither increasing nor decreasing. At that point, we write dy by dx is equal to 0. That means it is tangent to the x-axis, tangent parallel to the x-axis. Clearly, we can draw a line which is parallel to x-axis and touch the curve at that point. So, at that point, we can find the values of x. That value of x is nothing but the critical value of the function. So, here in this graph, we can say P is the critical point or critical value of the given function. Critical point is nothing but the point where the function neither increasing nor decreasing. It is stationary. So, here is the first question. Find the interval in which f of x is equal to 5 plus 36x plus 3x square minus 2x cube is increasing or decreasing. So, we have to find the interval where the given function is increasing and where the given function is decreasing. To find the increasing function, we know that f dash of x will be positive, and to find the decreasing, it means f dash of x is negative. So, using that concept, we can find the intervals. So, let's see now, they have given f of x. Let's find out f dash of x. F dash of x is for a constant, it is 0, 36 into 1 plus 3 into 2x minus 2 into 3x square. So, clearly we can write here 36 plus 6x minus 6x square. So, this is f dash of x given now. Now, we need to find out the interval for increasing and decreasing function. So, let's find out increasing. For a function to be increasing, f dash of x must be greater than 0. So, therefore, here 36 plus 6x minus 6x square must be greater than 0. Divide the equation by 6. You will get 6 plus x minus x square greater than 0, or minus x square plus x plus 6 greater than 0. Now, multiply with minus sign here, or minus 1 you can take. So, if you multiply, this becomes x square minus x minus 6. So, when you multiply or divide with the negative numbers, the inequality changes. So, here it becomes less than 0. Now, if you split this, you will get x square minus 3x plus 2x minus 6 less than 0, you will get x minus 3 and x plus 2 as a factors. So clearly what we can write here, x minus 3 is less than 0 or x plus 2 is greater than 0. So this is what we can write with the given inequality. So this implies x is less than 3 or x is greater than minus 2. Now, using this concept, we can see the interval where x belongs to greater than minus 2 means minus 2 comes first, less than 3. So this is the interval where the given function is increasing. Let's see for decreasing. For a function to be decreasing, f dash of x must be less than 0. That means 36 plus 6x minus 6x square must be less than 0. So divide by 6 again, or you can directly write the value as 6 plus x minus x square less than 0. So you can skip directly and write this as multiply with minus 1. You will get this as x square minus x minus 6 greater than 0. Because when you multiply with the negative sign of a number, the inequality changes. So you can skip the step because you have already done for the increasing function. Now again the same result, x square minus 3x plus 2x minus 6 greater than 0. So here we get x minus 3, x plus 2 greater than 0. So this implies x minus 3 is greater than 0 or x plus 2 is less than 0. So therefore what we can write here, x is greater than 3 or x is less than minus 2. So the number is greater than 3 means here x belongs to the interval. From this we can write x belongs to the interval 3 comma infinity. And here x is less than minus 2 means x belongs to the interval minus infinity comma minus 2. So therefore we can take the union of these two intervals. So therefore x belongs to the interval minus infinity comma minus 2 union 3 comma infinity. So this is the interval where the given function is decreasing, because from minus 2 to 3 the function is increasing. Before that and after that the given function is decreasing. Next one, find the critical or stationary points of the function f of x 2x cube minus 9x square plus 12x plus 6. When we say that the given function is stationary, or when we say we will get a critical point. So a function is stationary at the point where the derivative of a function is 0. So clearly let us find out f dash of x. It is 2 into 3x square minus 9 into 2x plus 12. So here we can put f dash of x is equal to 0 because we have to find the stationary point. To find the stationary point, we should take f dash of x as 0. So what is f dash of x here? This is 6x square minus 18x plus 12 is equal to 0. Now divide the equation by 6. You will get it as x square minus 3x plus 4 is equal to 0. So you can write x square minus 4x plus x plus 4 is equal to 0. So you will get it as x minus 4 x plus 1 is equal to 0. So this implies x is equal to 4 or x is equal to minus 1. So here if you divide the equation by 6, we get it as x square minus 3x plus 2 is equal to 0. So you can write the equation as x square minus 2x minus 6 plus 2 is equal to 0. You will get the factors as x minus 2, x minus 1 is equal to 0. So this implies x is equal to 2 or x is equal to 1. So we have two critical points. So therefore the critical points are 2 and 1. At this point, the given function is said to be in stationary condition, that is neither increasing nor decreasing, and a straight line which is tangent is parallel to the x-axis. Next question. Find the domain of increasing and decreasing of f of x is equal to x square minus 4x plus 3. Let's see now. Let's find out f dash of x. It is 2x minus 4. We need to find out increasing and decreasing domain of increasing and decreasing function. So for an increasing function, first condition, f dash of x must be greater than 0. That means 2x minus 4 is greater than 0. So here you can divide it by 2, we get x minus 2 greater than 0 or x is greater than 2. So this implies x belongs to the intervals 2, infinity. So this is the domain of the increasing function. And for the second one, f dash of x is less than 0, which means 2x minus 4 less than 0, x minus 2 less than 0, x is less than 2. So this implies x belongs to the interval minus infinity, 2. So this is the domain of the decreasing function and this is the domain of the increasing function. Next we have find whether the following are increasing or decreasing or neither, and also find the critical point if they exist. We need to find out f dash of x greater than 0, f dash of x less than 0, f dash of x is equal to 0. If it exists, we need to find the critical point. Let's see for the given function. Now let's find out f dash of x. F dash of x is given. Differentiation of x is 1. Differentiation of 1 by x is minus 1 by x square. Now 2 points are given. Now let's see at x is equal to 2. At x is equal to 2, f dash of 2 is equal to 1 minus 1 by 2 square means 4, which is 3 divided by 4. Clearly it is a positive. So therefore the given function is increasing at x is equal to 2. Let's see at x is equal to 3. F dash of 3 is 1 minus 1 by 3 square is 9, which is equal to 8 by 9. Again it is greater than 0. So therefore what I can write? The function is increasing at x is equal to 1, 2 and x is equal to 3. So it is clear that we got the positive values, that is f dash of x is greater than 0. So therefore it is increasing function. Now let's find out the critical point if exists. Let's check. Now f dash of x is equal to 0. This means 1 minus 1 by x square is equal to 0. This implies if you shift 1 minus 1 by x square that side, it is 1 by x square. So you will get x square is equal to 1. So this implies x is equal to plus or minus 1. So you got 2 points here. So therefore minus 1 and 1 are critical points. Next we have f of x is equal to e power x plus 1 at x is equal to 0. So let's differentiate the function. Differentiation of e power x is e power x. Differentiation of 1 is 0. So let's see at x is equal to 0. F dash of x is nothing but f dash of 0, which is e power 0 is equal to 1, which is greater than 0. So therefore f of x is increasing function. Increasing at x is equal to 0. Now let's see about the critical points. What is the condition of a critical point? F dash of x must be equal to 0. That means e power x must be equal to 0. But this is not possible. Exponential function can never become 0 for any point of x. So therefore, e power x plus 1 do not have any critical point. Why? Because not possible. For any value of a real number, exponential function can never become 0. So therefore, critical point does not exist for the given function. Next we have 4x cube minus 15x square plus 12x minus 2 at x is equal to 1 and minus 1. So let's find out f dash of x. So 4 into 3x square minus 15 into 2x plus 12. F dash of x is equal to 12x square minus 30x plus 12. At x is equal to 1, f dash of x is 12 minus 30 plus 12, which is equal to minus 6, less than 0. At x is equal to minus 1, f dash of x is 12 plus 30 plus 12, which is equal to 54 greater than 0. So what we can conclude, f of x is decreasing at x is equal to 1 and increasing at x is equal to minus 1. So now we need to find out the critical point. So what is the condition for a critical point? F dash of x must be equal to 0. Let's take 12x square minus 30x plus 12 is equal to 0. Divide the equation throughout by 6. So if you divide it, it is 2x square minus 5x plus 2 is equal to 0. So here 2x square minus 4x minus x plus 2 is equal to 0. If you take 2x common, x minus 2 minus 1, x minus 2 is equal to 0. So we get the factors as 2x minus 1, x minus 2 is equal to 0. So therefore, x is equal to 1 by 2 and x is equal to 2. So these are the critical points of the given function. Next question, find the value of x for which the function is increasing or decreasing. So let's look at the function. We have f of x is equal to 2x cube minus 15x square minus 84x plus 7. Let's find f dash of x. F dash of x is 2 into 3x square minus 15 into 2x minus 84 into 1. So therefore, f dash of x is equal to 6x square minus 30x minus 84. Now for a function to be increasing, f dash of x must be greater than 0. That means 6x square minus 30x minus 84 must be greater than 0. Let's divide the equation or the inequality by 6. If you divide this by 6, we will get x square minus 5x minus 12 greater than 0. So if you divide the given equation or given inequality by 6, we will get the equation x square minus 5x minus 14 here greater than 0. So then we will get it as x square minus 7x plus 2x minus 14 greater than 0. We get the factors as x minus 7 and x plus 2 greater than 0. So here let's look at the interval. We can write x minus 7 greater than 0, x plus 2 less than 0. So this means x greater than 7, x less than minus 2. So therefore, what we can conclude here, x belongs to the interval 7 comma infinity and here x belongs to the interval minus infinity comma minus 2. So therefore, the given function is increasing in the interval minus infinity comma minus 2 union 7 comma infinity. So whatever you get greater than 0, take x minus 1 as greater than 0, the second function as less than 0. Now let's look at for the decreasing of the given function. So for a function to be decreasing, f dash of x must be less than 0. So for that function, what is the given function I have got there? It is x square minus 5x minus 14 less than 0. We have got the factors as x minus 7 and x plus 2 less than 0. So this implies what? take x minus 7 as less than 0, x plus 2 as greater than 0. So this implies x is less than 7 and x is greater than minus 2. From these two observations, clearly I can write x belongs to the interval less than 7 and greater than minus 2. So this is where the given function is decreasing in the interval minus 2, 7. Let's look at for the second question. We have f of x is equal to 2x square minus 96x. So here, let's see f dash of x. We get x square as 2x. So it is 4x minus 96. For a function to be increasing, f dash of x must be greater than 0. So this implies 4x minus 96 greater than 0. If you divide this by 4, we get x minus 24 greater than 0. So therefore, x is greater than 24. Therefore, the interval is 24, infinity. So this is the interval where the given function is increasing. Now let's check it for the decreasing condition. So this implies x minus 24 less than 0. This implies x is less than 24. Therefore, x belongs to the interval minus infinity, 24. Here, the given function is supposed to decrease. So in today's session, we have learned how we can find whether the given function is increasing or decreasing by the help of derivatives. We'll meet you in the next session. Until then, keep watching, keep learning, and keep exploring. Thank you.